Here's the lesson on factoring. First of all, I look to see if there is a GCF with all of these. Make sure you check for GCFs. GCF is a number that will divide into both of these. It's also involved with the letters and exponents. We'll start focusing on the the numbers. Here 81 and 3 both are divisible by 3. So really what you're doing is you're taking, or with numbers dividing, both of them are divisible by 3, so I'm taking that value. And I'm going to show you what I took. I don't want anybody to think that I just stole it, threw it away. I'm going to show it. So 81 divided by 3 would leave me with 27. 3 divided by 3 would leave me with just the 1. I'm leaving space in here because I'm going to take other items. Now I look at the letters of U. This one has 1. This one has 4. You have to take what both of them can give you. I'd like to take 4, but this term here can't afford 4 U's. So the most that I can take from both is a U. Well, when I take the U from there, there's nothing. When I take a U from here, I become 1 less. Went from 4 to 3. Now I have V to the 5th, V to the 3rd. The most that I can take from both is V to the 3rd. So when I take that 3 from the first term, I have V squared. When I take V to the 3rd from the second one, I'm left with just that item. In other words, it disappears. I need to keep my sign in front. What we have here is a factored version. If I would distribute this through, then I would end up with the same original problem. That's GCF. Always look for GCF first. First. Next one. Again, we have 2 terms. Remember, terms are separated by pluses or minuses. So in this case, we have 2 terms. I'm going to look for GCF first. Both are divisible by 9. So I show that off. That would give me a 9 here and a 1 there. No letters, so I'm going to rewrite them. Now, a lot of people want to stop here. To factor completely, we show that we took the 9, but we also have to look inside this set of parentheses and check, since it's 2 terms. If you go down your flow chart on 2 terms, you look for a difference of 2 squares. Remember, 2 squares is perfect squares. 1, 4, 9, 16, 25, and so on. Also even exponents. So in this case, this is a difference of 2 squares. So I'm going to still show that 9. Please don't forget to bring that down. It is a common mistake. And this breaks up into 2 binomials. Square root of the first is 3 and x. That will be the first term of both. Square root of the second, y. And then I call them almost twins. They look exactly the same here, except one is a plus and one is a minus. That is considered factored completely. Now we go to the third one, and we have 3 terms here. 2 plus, a plus and a minus, so 1, 2, 3 terms. So this is where we play the game. We're looking for 2 numbers that multiply to give you negative 12 and add to give you this value here, which unwritten is 1. So I'm looking for factors of 12. 1 and 12, 2 and 6, 3 and 4. Which one of those can I make into a positive 1? Well, these 2 obviously. Only if 4 is positive and 3 is negative. Those are the 2 factors that I will write. So first 2 terms have to multiply to give the first, and then minus 3 plus 4. I can check it real quick. Do the first 2 multiplied together equal the first? Do the last 2 terms multiplied together give you the last? And negative 3x and 4x added together give you the middle term. In this case, yes. Same type situation, number 4. A lot of people poop our pants because we see x to the 4th and this x squared and we don't know what to do. Same thought process. Two numbers that multiply to give you the last and add to give you the middle. In this case, it has to be -4 and +1. Well, what two terms multiplied together will give you the x to the fourth? X squared. So check it real quick. X squared give you the first. Last two give you the last. Add them together. Two smiles. I always say two smiles give you the middle term. And that's all true. Now, always double check when you see a squared to see if this is a difference of two squares. And in this case, yes, it is. Perfect square minus perfect square. So that factors again. Square root of the first, square root of the last, and almost twins makes it a plus minus. I also need to bring this term down, or this factor down. That is factored completely. The last one, GCF first. What can I take from both of them? I got a and Q. So when I take a P from here, I'm left with P squared, no Q, minus 1. Hopefully you're noticing that that's a difference of two squares. So I bring down the PQ. This factors into difference of two squares is almost twins. P, 1, 1, plus and a minus.